So using that power, we can electrolyze salt water in a 4-chamber container. From each chamber we get a different byproduct with different applications. Chamber 1 releases pure oxygen. From chamber 2 we get sodium hydroxide. Chamber 3 produces hydrochloric acid. And from chamber 4 comes hydrogen. The oxygen can be vented off into the atmosphere because we can never really have too much oxygen. Hydrogen can be collected and stored and used as fuel for the new generation of hydrogen cars. The hydrochloric acid can be used in mining operations to break down rocks. The world's most common mineral, olivine, is just about the best candidate for this process, and the one we're going to use. When you dissolve this common rock in hydrochloric acid, you get magnesium chloride, iron 2 chloride, and salicylic acid. The salicylic acid gets put in a dryer to evaporate off all the water, which leaves you with fumed silica. This is the material that computer chips are made of, so you can sell this off to Intel and help fund the rest of your operation. But computer chip manufacturers won't be able to use all of the fumed silica being produced. Silica is a natural base that can help reverse the increasing acidity of our oceans and feed the phytoplankton that help make our underwater ecosystems thrive. The magnesium chloride that's produced can also be heated up, but that's got to get to a melting temperature. When you electrolyze the molten magnesium chloride, you're left with 2 products: magnesium metal and chlorine gas. The magnesium is worth about $3,400 American per ton, so this can help fund the operation. But the chlorine gas is really the important part in this, because you'll need it in the next step. The rest of the molten magnesium chloride gets combined with washing soda and heated up to a molten temperature, producing magnesium oxide, salt, and carbon dioxide. The magnesium oxide can be added to ordinary cement to make a much stronger, more durable cement that holds up particularly well when exposed to seawater. The carbon dioxide that's given up can be filtered back through the sodium hydroxide to make more washing soda and baking soda. But the really important aspect of this tank is that by pulling air from our atmosphere, it can literally filter the greenhouse gases right out of the oxygen we breathe. When you combine the chlorine gas that's burned off the magnesium with the iron 2 chloride you got from the olivine, you get iron 3 chloride. At this point, sodium carbonate and water are added to the iron 3 chloride. This combination of sodium carbonate, water, and iron 3 chloride produces ferric hydroxide. And when you put ferric hydroxide in a dryer and cook off the water, you're left with pure hematite. This process also has a couple byproducts. One is salt, and the other is carbon dioxide. The carbon dioxide gets funneled back into the tank to be combined with the extra iron 2 chloride and washing soda. This tank produces iron carbonate and more salt, which can be recycled back into the original 4-chamber tank and mixed with water evaporated off the fumed silica to start the whole process over again. This tank produces iron carbonate and more salt, which can be recycled back into the original 4-chamber tank and mixed with water evaporated off the fumed silica to start the whole process over again. Hematite is the ore that's used to make iron, and usually it's very expensive because it has to be mined using explosives, huge trucks, and grinding mills. But because in the 4C process it's all coming from the rocks underneath our feet, it can become much cheaper. This means that iron could potentially replace lumber as a building material, so all those oxygen-producing forests that would otherwise be turned into gases could be replaced with iron and keep giving off oxygen. So to recap, the 4-chamber electrolysis process can stabilize our power grid, produce useful raw materials, balance the pH of our oceans, make stronger cement, save the trees, and filter carbon dioxide out of our atmosphere. And this is all possible with only salt water, electricity, the rocks under our feet, and a few people that are passionate enough to bring it all together.